It is time of the health checkup for the project time schedule. The following guidance implemented by international associations as SCL, Society of Construction Law. India, National Defence Industrial Association, L, Society of Construction Law. India, National Defence Industrial Association, DCMA, U.S. Defense Contract Management Agency. Oracle, Primavera Risk Analysis. This lecture about the schedule health assessment metrics does not provide thresholds, but rather threshold guidelines that serve as trigger points for additional analysis. The importance of metrics and the guidelines or standards may vary by program phase and/or program type. Programs should define the exclusions to the calculation of their metrics. Is often the number of tasks that miss the mark. SCL recommendations. 1. Format, the duration, start and finish dates of the activities as well as their interdependencies. Most convenient format, particularly for hard copy, is a linked bar chart cascade diagram which shows the planned. 2. Duration. The maximum duration of an activity in the program may be specified in the contract, depending on the complexity of th project. As a guide, no activity and a summary activity should exceed 28 days in duration. 3. Details. Wherever possible, an activity should encompass not more than one trade or operation. 4. Logic links. Activities should be linked together by the appropriate logic link such as finish to start, start to start and finish to finish. 5. Lags. Lags may be introduced for non-work periods such as curing of concrete, but better visibility and understanding is provided if such matters are shown as activities in themselves. Activities to be executed by use of overtime and/or additional shifts should be identified and explained. There should be no negative lags or open-ends hanging activities that would produce false criticality. Excessive leads and lags should be avoided. If requested by the California, the contractor should provide an why particular leads and lags have been applied. 6. Constraints. Manually applied constraints such as must start or must finish fixed dates, zero float and other programming technique that can have the effect of inhibiting the program from reacting dynamically to change should be avoided. 7. Resources. Key resources such as labor, including that which relates to design where relevant, tradesmen, major plant items, dedicated resources, major materials and work rates should be indicated for each activity. 8. Method. The program should be prepared using the activity on node precedence method rather than the activity on arrow method and should show the operations to be undertaken in sufficient detail to provide proper forward visibility. India, National Defence Industrial Association. From a merger between the American Defense Preparedness Association, previously known as the Army Ordnance Association, founded in 1919, and the National Security Industrial Association, founded in 1944. India Integrated Program Management Division issued the Planning and Scheduling Excellence Guide, PASEG, which include the following schedule health check. 1. Missing logic. Link discrete tasks to ensure a meaningful calculation of total float and projection of accurate forecast dates. Metric expressed as number of tasks without a predecessor or successor or the percentage of tasks without logic. Tasks with a SS successor or FF predecessor are often included in this list. 2. Use of leads. Acceleration of a successor activity. Leads may distort total float and the critical path. The reason a lead was used should be documented and have proper justification. The critical path may be adversely affected by the misuse of leads. Metric expressed as number of tasks with leads or percent of tasks with leads. Additionally, Metric may be bounded by the size of the lead. 3. Use of lags, delay of a successor activity. During the status process, task owners often overlook updating lag values, which can result in an inaccurate predictive model. The reason a lag was documented and have proper justification. Metric expressed as number of tasks with lags or the percentage of tasks with lags. Additionally, the metric may be bounded by the size of the lag. 4. Relationship types. A relationship type such as start-to-start (SS) or finish-to-finish (FF) can cause resource conflicts when the tasks are dependent upon one another while also taking place at the same time. The start-to-finish (SF) relationship type is counterintuitive. The successor can't finish until the predecessor starts and should only be used very rarely and with detailed justification. Metric is often the percentage of each relationship type. 5. Hard constraints, such as must finish on and must start on. Using hard constraints prevents logical predecessors driving tasks, or prevents the schedule from being logic-driven. The critical path and any subsequent analysis may be adversely affected. Metric is often the percentage of each type of constraint. 6. High float, high slack. A task with high total float may be a result of inaccurate predecessors and/or successors. If the percentage of tasks with excessive total float is high, the network may be unstable and is not being logic-driven. Ensure that health metric thresholds are appropriate for the relative length of the program and consistent with oversight requirements. Metric is often the number or percentage of high-float tasks. Ensure the numerical definition is consistent with the overall length of the program. 7. Negative float. A task with negative float is potentially driving key program milestones past contractual date requirements. Measure the number or percentage of tasks with negative float. 8. High task duration. Higher duration tasking may not provide the necessary precision for future measurement of work completed without significant additional effort on the part of the program. Measure the number or percentage of tasks with high duration. The SAO or CDRL often expresses duration limits to ensure sufficient granularity of the schedule. 9. Invalid forecast dates. A task should have forecast start-finish dates that are in the future relative to time now. Measure the number or percentage of tasks with invalid forecast dates. 10. Invalid actual dates. A task should not have actual start or actual finish dates that are in the future relative to time now. Measure the number or percentage of tasks with invalid actual dates. 11. Invalid actual dates. A task should not have actual start or actual finish dates that are in the future relative to time now. Measure the number or percentage of tasks with invalid actual dates. 12. Resource loading. Where resource loading is a requirement, all tasks should be resource loaded, other than summary, milestones, schedule margin and tasks. The number or the percentage of non-resource loaded discrete tasks is off. 13. Tasks without baseline. All tasks should have baseline elements from which the performance measurement baseline (PMB) is established. Measure the number or percentage of tasks without baseline elements. 14. Summary task logic. Summary tasks with logic can result in incorrect schedule date calculations or at a minimum, can reduce the precision of the schedule. Measure the number or percentage of tasks with task logic. 15. Out-of-sequence status. Out-of-sequence tasks are those tasks where the execution is contrary to the logical relationship of the tasks. Typically, this occurs when an incomplete predecessor is driving a started task. accurate successor path forecast dates, and total float calculation. Measure the number of out-of sequence tasks. 16. Over-allocated resources. Resource-loaded schedules have the ability to show over-allocations that may hinder program progress. Measure the number of tasks with over-allocated resources. 17. Vertical schedule integration violations. All tasks should flow up to their summary tasks. Errors here limit the use of summary schedule to portray accurate program status. Measure the percentage of tasks that fail vertical integration checks. In 2005, U.S. Defense Contract Management Agency implemented a 14-point schedule assessment to help them evaluate the enormous volume of contracts and schedules they were tasked with managing. These best practices are broken down into a list of 14 checks. 1. Logic. Is the schedule logical? Schedule logic involves schedule tasks. Are all the successor tasks concurrent? Missing links need to be resolved because without schedule logic an accurate critical path will not be possible. 2. Leads are not allowed in scheduling as they are confusing and disrupt the flow of the schedule. Leads are often replaced with positive lags, but this isn't always the best alternative. It is better to have shorter known scopes of work tasks connected by FS relationships, with no lags. 3. Lags. The DCMA does allow positive lags, but it's in a schedule. The limit for lags is no more than 5% of activity relationships. The best option is to replace lags with tasks describing the effort or process, such as cure time. Lags are limited to 5% in order to support schedule clarity. 4. FS relationships. Even though Primavera P6 and Deltek AcumenFuse both support all relationship types, the DCMA assessment states 90% or more of schedule dependencies should be finish start FS. Start SS are, but building a whole schedule using SS is obviously unacceptable. 5. Hard constraints can really affect logic and disable a schedule from being logic-driven. The DCMA assessment states that hard constraints should be limited to 5% of uncompleted tasks. Any type are discouraged and a schedule should work without any. 6. High float. Activities may not be linked properly and can cause stress on the critical path. Total float values are limited to 44 days. Therefore, review tasks that have greater than 2 months total float and 2 months total float and limit their usage to 5% of incomplete tasks. 7. Negative float. Schedules that have negative float tasks are already behind. Ideally, the DCMA says avoid having negative float in your schedule. If there is negative float, make sure it is accompanied with a documented plan to mitigate being late. 8. High duration tasks. Limit long duration tasks to 5% of incomplete tasks. Task durations should be no longer than 2 months in order to support schedule updating and reporting. Break long activities down into a series of shorter ones for more detail. 9. Invalid dates. Forecasted future work. Work should not be in the past and actual, completed work. Work should not be in the future. Invalid dates are not allowed under any circumstance. This will avoid illogical situations where future work is planned for the past and completed work happened in the future. 10. Resources. Resource loading is not a requirement, but the DCMA likes schedules to be resource and cost loaded. This path makes sure the resource-loaded schedule is completely loaded. All activities except milestones must have a cost or associated resource. 11. Missed tasks. This check looks at how many activities have finished late compared to the baseline date. Monitoring excessive slippage. Only 5% of activities can slip from their finish baseline dates. This metric is a conservative and retrospective measure of schedule progress, but it's a good generic check to see if your project will deliver on time or not. 12. Test. Ensures the schedule has one continuous linkage from project start to finish. It tests the integrity of a schedule's critical path, looking for fluidity driven by good logic linking. 13. Critical Path Length Index. The Critical Path Length Index (CPLI) is a forward-looking gauge that assesses required efficiency to complete the project on schedule. It measures the ratio of the project critical path length and the project total flow to the project critical path length. The critical path length is the time in work days from the current date to the completion of the project. The target number is 1.0 and schedules that have a CPLI less than 0.95 require further review. 14. Baseline Execution Index. The Baseline Execution Index (BE) is an early warning indicator that a schedule is in trouble of not meeting the deadline. Most scheduling software doesn't have a BE variable, but it is possible to compute the ratio yourself or purchase an additional scheduling software supplement. The BE ratio's advanced, non-trivial, and purposeful warning makes the computation worth the effort. A BE of 1.0 means that the schedule is on the right track. Primavera Risk Analysis (PRA) is one of the leading tools for risk assessing your project schedules. PRA is used to perform schedule validation and embed your own risk models with fully developed risk events. Schedule checklist for Primavera Risk Analysis. 1. Constraints. Schedule constraints have a significant effect on risk analysis results. They should be used carefully. 2. Open-ended tasks. An open-ended task is one of at least one predecessor and one successor. It indicates a possible lack of logic. 3. Out-of-sequence updates. The logic in a plan can be broken when tasks have started or finished before their predecessors. It is recommended that any broken logic is removed or corrected to ensure the project schedules as expected. 4. Lags longer than 0 units. Lags cannot have risk or uncertainty. Replacing the lag with a task so that uncertainty and risks can be assessed against it. 5. Negative lags. Consider replacing kind of link that does not need the lag. 6. Positive lags on finish to start links. Use the Convert Lags to Tasks tool when a project contains a large number of long lags. 7. Start-to-finish links. Consider whether this logic might be a mistake. Especially if it is between tasks that are not milestones. 8. Lags between tasks with different calendars. When the two tasks have different calendars, it is not clear which calendar the task will use, whether it is the preceding task's or the succeeding task's calendar. Replacing the lag with a task so that its calendar can be explicitly defined. 9. Links to or from summary tasks. Consider removing logic on a summary task by using a milestone to Things to promote. The ability to use the schedule to predict future performance requires a sound schedule. Ensure the program is addressing schedule health concerns in a logical order of precedence. Address items with the biggest deviation. Established standards first. Communicate the reason for performing schedule health metrics to all of the task owners, not just to the planner or schedulers. Ensure that health metric threshold guidelines are appropriate for the relative length of the program and consistent with oversight requirements. Regular use of a schedule health assessment and to be provided to the customer. Things to avoid. Avoid creating an environment driven to eliminate variances to the metric standards as the primary goal, as this objective typically drives bad behavior and will likely result in an erroneous schedule. Do not let the metrics drive the schedule, rather the schedule health should be reflected in the metrics. Avoid viewing all schedule health metrics as a pass or fail mechanism, but rather an analytical tool for discovering areas that may need further focus and/or clarification. Thank you. Kindly subscribe, like, comment and share.